Hi guys, have you guys met with this type of equation? It seems very hard to solve, right? Worry not, because today, this video, we will explain on how to solve this type of question by using two methods, elimination row method and also matrix method. Under elimination row method, or we call as ERO method, we have Gauss or Gauss-Jordan elimination method. And under matrix method, we will have inverse matrix Cramer's rule that we will use. So now let's
take a
at
look.
one example in real life situation. Ain, why you look so stressed? What's the problem?
Oh, hi Runa. Actually,
She's
I've
having
been
a problem.
confused with this question. I've been thinking this 2 days, 2 nights during
Oh my
eating,
God.
when shower. Can you solve this question?
This type of question can be solved by using ERO method or matrix method. I just taught them just now.
Wow!
Oh. Yes. Let me explain to you.
Let's go.
First, we need to identify the unknown in the question. So, the unknown for this question is I1, I2 and also I3. And then we will use first Kirchhoff law and second Kirchhoff law. So, for the first Kirchhoff law, the total current in will be equal to total current out in a junction. So, if we take a look at this junction, the total current in is I1 and I3 will be equal to I2. And for the second Kirchhoff law, the total volt will be equal to total current times with resistance in a loop. So for the loop 1, total current, the total volt will be 20 minus 10 because of the opposite direction with the loop. So it will be 10, and also for the IR, it will be 8 times with I1 and also 10 times with I2. 10 times with I2. And then for the second loop, the total current will be 12 minus with 10, and also the current, the IR will be 8 plus 10 times with I3 and also 10 times with I2.
Oh, now I get it. A lot more easier than what I thought. But wait, we got the equation, right? How to solve it?
Let's take a look then.
First method, Gauss elimination method.
Hello guys, today I'm gonna teach you how to solve the equation using Gauss elimination method. So first, for Gauss elimination method, we're going to turn this 3 into 0. So first step, we're going to turn this into 0, but it's already 0, so it's okay. And then the next step, we're going to turn this into 0. So for you to turn this to 0 is row 2 equal to negative R1, row 1 plus row 2. So it's going to be, for the first row is going to be the same, but it's going to change for row 2 is 0, 18, negative 8 and 10. And for the row 3 it's remain the same also. So and then we're going to turn this 10 into 0, and for that row 3 equal to negative 5 row 2 plus 9 row 3, and then we're gonna get 1 for the first row is remain the same, for the second row is also the same, but it changed when to the row 3. The row 3 is gonna be 0, 0, 202 and negative 32. So from the equation, we're gonna get 202 I3 equals to negative 32. I3 equals to negative 0.158. And then we're gonna substitute I3 into the next equation, that is 18 I2 minus 8 I3 equals to 10. I2 we're gonna be 0.485. And then we're gonna substitute these two I2 and I3 into the last equation, that is I1 minus I2 plus I3 equals to 0. So we're gonna get I1 equals to 0.644. That's all.
Okay, for the next method, we have Gauss-Jordan elimination method. For this method, it's actually same with the previous one, but a little bit different, which is for this Gauss-Jordan elimination method, you have to eliminate these two parts becoming 0, while before this, you have to eliminate only this part and becoming 0. Okay, for example, for this question, my first equation is I1 minus I2 plus I3 equal to 0. The second equation is 8I1 plus 10I2 equal to 10. And the third equation is 10I2 plus 18I3 equal to 2. Okay, then I substitute the value at this formula, which is 1, negative 1, 1, 8, 10, 0, 0, 10, 18. And this is x, which is this value, y, this value, and z, this value. And then first I eliminate this first to becoming a 0. I use this formula and I get the value here 0. And then after I get this 1 0, I check this row. It's actually already become 1 0 0. Then I do this for the second step. I eliminate this one and becoming 1. I'm using this formula and I got it 1. And then I use for the third step. I eliminate this, the up one, using this formula, and then I got it 0 here. And then for the next step, I eliminate this, the bottom one, to becoming 0. I use the formula R3 equal to R3 minus 10 R2. Then I can get 0 value here. And for the next, I eliminate this one number, and then I got the R3 equal to 18 over 404. R3, I got one value here. And then I eliminate this one to becoming 0 by using this formula, and then I eliminate this and becoming 0 using this formula, and the final answer I got 1 0 0 0 1 0 and 0 0 1 at this part. And this part I got net 65 over 101, and then 10 over 18 and negative 64 over 44. Okay, we look at this part. It's already become 1 0 0 and 0 1 0 and 0 0 1. So we already can calculate the value for I1, I2 and I3 by using simultaneous equation using your calculator. So here I got I1 equal to 0.644. For I2 I got 0.485. And then for the I3 I got negative 0.158. That is how we do it.
So now I'm going to explain to you guys the third method, that is inverse method. Okay, so from this equation, we need to change it to matrices A, X and B. So to find the X, I1, I2, I3, we need to insert it in this equation, A inverse B. So we need to find A inverse. So for A inverse, there are two steps, determinant and adjoint. So for determinant, we take this third row, 0, 10, 18, and then the symbol positive, negative, positive. Then inside of this, let's say we take this 0, we close this and we close this. That's why we get negative 1, 1, 10, 0. So we same to the others also, and we calculate all of this and we get 404. Next, for adjoint A. So first we put positive, negative, positive, negative, positive, negative, positive, negative, positive. For this inside number, we look back at A. So it was at first column and first row. So we close it, and that's why we get 10, 0, 10, 18. Apply it also to the other side. And for the outside, T means transpose. So then we calculate all of this using using AD minus BC. So that's why we get it like this. And we transpose it become like this. After we find the adjoint A and determinant, so we can find the A inverse. A inverse is equal to 1 over determinant multiplied by adjoint A. So the number that we got earlier, we can insert in the formula and we calculate it. We will get like this. And then for I1, I2, I3, we can multiply A inverse with B. We calculate it and we will get like this. So the final answer is I1 equals to 0.644, I2 equals to 0.485, I3 equals to negative 0.158. That's all.
So, the last method to solve this problem, we will use Cramer's rule. First thing, do the coefficient, which is I1 negative I2 plus I3, and we put 1 negative 1 1. Also the other equation. And then first focus on the 1 and close the row and the column and we get 10, 10, 0, 18. And do the same thing with this. And then we know that this one is positive, negative, positive, which is negative, negative, we will positive. And then in this determinant, 10 times 18 minus 10 times 0, and also do the same thing and we will get 404. And for I1, do the same thing, but in the column of x, we replace it with the sign, the equation sign. So the equation sign is 0, 10, 2. And this column and this column do the same thing. And then by using the same method, we will get 260. And to get I1 divided by I, and we get this answer. So for I2, we replace this equation sign in the y column. And then close this and this, we will get 10 to 0, 18. I put here. And also do the same thing and multiply it and you get the answer for I2. And I2, to get I2 divided by I, and you will get this answer. So for I3, replace the equation sign in the z column, which is this one, and x and y do the same thing and multiply it and you get the negative 64. And for I3 divided by I, and you will get this answer.
Maybe no one knows if I disappear.
Thank you for watching.